Hello everyone. Today we'll be solving the problems of chapter number 9. So let's start. In first question, he said find edge at the center of a square current loop of side L. So you have a current loop like that as shown here. So the length of each side is L. Now it is required to find edge at the center of that loop. To solve this question, it is recommended to make or to choose certain plane. Simply if you take XY plane, then you have to take into account to be light in somehow as shown here. So in this case you have the center 0, 0, 0, which is the origin, and if you look at this loop, at each side you have L by 2 plus positive, or on the other side you have minus. Also for y-axis you have positive, negative, L by 2. The main idea is to use Biot-Savart law for just a small portion of this loop. So it will be taken, the portion that will be taken is this portion will be taken, as you can see in the figure, which is light between, as shown here, for extend for x equals 0 to L by 2, and lying at y equal minus L over 2. Now if you apply Biot-Savart law, so Biot-Savart law will be this one, okay, this is the Biot-Savart law. Now you have to know what's the vector, the distance vector. The distance vector as shown here, may I zoom it just to know? If you select this portion, then you have to identify 2 points. For example, this point will be the origin 0, 0, 0, no doubt about that. The other point will be arbitrary x and fixed y and fixed z also. Z will be 0 and y will be minus L over 2, and for any x value. So by this assumption you can figure out the vector equation. So you'll say 0 minus x, it will be minus x ax, and you'll say 0 minus L over 2, it will be plus L over 2 ay, and this will be for z you'll get nothing, because 0 minus 0 it will gone. Now for the length of this vector, you have to square the first, square the second, and taking the root square for it, you will get the length of this vector. And also for the unit vector, this will be the unit vector. Getting back to the main equation, now you have to substitute IDL, a cross product with unit vector. So IDL, it is very obvious that DL here will be dx, so IDX AX cross product with the unit vector. Unit vector already taken from here, okay? So for now, for performing the cross product, you will be needing just for upper side, okay? The lower side already will be multiplied with the length, and the length, the order of the length is 1, and will be multiplied I mean, because it is root square, so if you square it again, it will be rise for order of 1, then will be multiplied with this amount, okay? So already this raised to a power of 1 over 2, so you have 1 plus 1 over 2, it will be 3 over 2. For that reason, at the denominator you get this factor. Just something worthy to be mentioned, this is x actually, not r. We don't have r here in this system. It is by mistake written to be r. It is x, okay? So when you perform the cross product, you have to perform it like given here. So already it is previously mentioned how to find the determinant for such cross product. You can find it easily. The answer will be this. So this will be substituted at the numerator. And don't forget that you have I also. It is missing here. So you have I L over 2 dx az. All of this will be substituted in the upper equation, and the denominator will stay the same because no operation will be taking place here. Just the cross product will be affecting the numerator. Now it is ready for integration. Why? Because it is differential magnetic field. You have to calculate magnetic field from it. It will be taken by by having double integral, by having integral for both sides of equation, single integral. Why? Because at the denominator you have just dx. For that reason you have to identify the limit of integration for that dx. Don't forget this portion taken from x equals 0 to x equal L over 2. So this will be substituted for limit of integration. And don't forget, you have to multiply this amount calculated from here, okay, by 8. Why? Because this piece, if you have four-side loop like shown here, it's composed of four sides, and each side composed of 2 half sides. For that reason, you have to multiply by 8 to calculate the total magnetic field produced by the whole square loop. So for that reason, we multiplied here by 8, and this is the limit of integration for this piece. And here, anything stay constant, anything not variable will get out, like 8 already, it is out. I L over 2 also will get out, 4 pi also. Then you get this, just this integration to be integrated. So if you get back to problem 2.9, from this problem already we derived such integral. The problem here that you don't have the derivative of denominator upper side as the numerator. For that reason, you have to follow some tricks or some methods in mathematics to find the answer of this integration. The trick will be by transforming from algebraic form to sinusoidal or trigonometric form by following either sine formula or tangential formula. I think here you have to follow tan and secant formula as done in 2.9. So directly, if you take the result from 2.9, this will be the result. This will be the result. Just you have to substitute in the limit of integration, then you get whatever you're looking for. So this will be the answer for the integration part. Okay. So this section, this term, will be equal to this Now after getting the answer, you have to multiply by the rest of equation, then you get this value as the required magnetic field to be calculated. Now it is time to talk about question 9.3. In this question, he said a current sheet, may I zoom it somewhat? A current sheet K equal 10 AZ lies in X equal 5 meter plane, and a second sheet K equal minus 10 AZ lies at X equal minus 5. So you have positive value current sheet at the positive X, you have negative value current sheet at the negative X, and so on. Find edge at all points. So here in this case you have to know that previously in a certain example we solved such case and the result will be directly like that. So you can use it as a formula, as a ready formula to be used, and no need to apply Ampere law here for each side and following every single step. It is apparent that at any point between the sheets we have this formula, okay? 1/2 current sheet density cross product with AN, which is unit vector of the normal vector, which is the normal on the plane for each sheet. Then for the space between -5 to 5, okay, I think by mistake it is directly taken from the textbook, but there is mistake in here. This is -5, not -3, okay? Even it is printed like so in the textbook. Anyhow, so in the first region we will take the region between both planes from -5 to 5. For this region, 1/2 10 multiplied by minus AY. How to get minus AY for this case? From the left sheet. So if you look at whatever you have from the left sheet here, you have the current sheet density directed downwardly, and you have the normal component directed like that. So you have to make cross product between them to get the answer. So cross product, how to be performed? If you imagine that this is the current sheet, then fold your fingers like that to be directed toward the positive X plane. Then your thumb, which is directed outside the sheet, this will be the direction resulted, okay? So this direction will be to the negative Y direction. Why? Because the positive Y is directed inside the sheet, okay, while I mean the sheet of this paper, not the sheets of the current, okay? So very clear that according to the right hand rule, you will get the direction of cross product between both of these vectors to be minus AY. While if you think about the other side, so you have current sheet density directed upwardly, then make it cross product with the A normal, then you get you get the direction of the field will be again directed minus AY. For that reason, they will not cancel each other, otherwise they will be duplicating each other. I mean, you will get 2 times the field amount produced by each one of these current sheet densities. Anyhow, you will get the negative sign will be maintained for both parts, okay, and the result will be 5 here, 5 here will be added to be 10. So you get H total to be 10 minus AY, 10 minus AY. So if we get back just to whatever required from us, find H at all points. What if we think about other regions? What if we think about other regions? For example, for x more than 5 and x less than 5, less than minus 5. For here, for this region, okay, if you imagine that it will be like a circles, the magnetic field. As you're talking about the direction of the magnetic field produced, it will be directed like that. So if you follow the mouse here, this will be the direction of rotation for the magnetic field produced from this side. Now, if we talk about this side, the direction will be AY. What about the field produced here? If you imagine a bigger circle to be like that. So it is very obvious that this direction is minus AY, while the previous one is AY. For that reason, cancellation will be taking place because you are talking about two circles, two rings like that, okay? So these rings will be like that, will be directed, okay? Now if you imagine for this side, for the other side, it will be rotated like that, okay? I wonder if you can imagine it, okay? Now if you imagine another circle bigger like that. So here the direction will be directed oppositely. For that reason, cancellation will be taking place on both sides of for x more than 5 and x less than minus 5. Let's go to the other question. Question number 4. In this question, he talking about a thin cylinder, okay, a thin cylindrical conductor of a radius A, infinite in length, carries a current of I. Find H at all points using Ampere's law. Now, this is the case. We have a cylindrical conductor like that. Now, it is very obvious that it is hollow cylinder. Why? Because he said a thin cylinder conductor of radius A. Okay, so getting back to whatever we have here, if I zoom it just to understand, you have this cylinder. So if you apply Ampere's law here, how many regions you have? Sure, you will have two regions, inside and outside. So if you start to think about the inside region, okay, for the first region, you have to follow the formula of Ampere saying closed integral equal to closed integral of H dot dl equal to I enclosed. Now how much I enclosed in this case, even before thinking about H dot dl? How much I enclosed if the current will be flowing through the cylinder, the hollow cylinder itself. So it is not solid cylinder, it is hollow cylinder. For that reason, inside that hollow cylinder you don't have any current, so I enclosed equals 0. For that reason, magnetic field also will be 0, even before thinking about integration of H dot dl. If you want to think about it, it will be just integrating this path. So this path is closed circle, how much the length of a closed circle, it will be the circumference of it. Circumference will be 2 pi r. Taking the integral of h dot dl will be producing this amount, 2 pi r h phi equal to I enclosed. Let's go to the second region, region number 2. Region number 2 outside the cylinder. So region number 2, if you think about it, here, how much is the I enclosed? I enclosed will be the total I we're talking about. So I enclosed exists in this case, which is non-zero result. It will be equal to I. And again, if you talk about the right side, the left side of the formula, you have to take into account the closed integral. The closed integral of dl will be 2 pi r. Okay, so the result will be I over 2 pi r. Okay, so if you think about whatever you get here, it is the same as the filamentary or the small filament having a certain current, or a small a thin wire having current, as solved in previous examples in this chapter. As mentioned here, the same field as that of a current filament I along the axis. Why? Because it is obvious that Ampere law did not depend on whatever be the current flowing through a circular cross-section material or rectangular cross-section material, but depend on the amount of that current being enclosed by Ampere path. Jumping to the other example, so example 9.5, or problem 9.5, determine edge for a solid cylinder. In this case, you have solid cylinder, unlike the previous one. A conductor of radius A, where the current I is uniformly distributed over the cross section. To solve problem 9.5, we have to know that we have a conductor like that, okay, with radius of A. Now you will have two regions. You will have this region and you will have this region. So region 1 and region 2. For region 1, for region 1, you will say edge dot dl equal to I enclosed. Now edge dot dl, very easy, it will be 2 pi r multiplied with edge as magnitude. We don't know yet how much will be, or where will be the direction of this magnetic field. That will be concluded after that. Now about I enclosed, how much is I enclosed? I enclosed, if you look at whatever you have here, these are the directions of the current we have. Okay, so how much is the total amount of current passing through this section? In this case, you have to say it is J multiplied by this area of Ampere path. Okay, so area of Ampere path, it will be pi r square. Now how much is J? J must be the total amount of current over pi A square. If you multiply both, then you get this result. It will be I multiplied by pi R square divided by pi A square. On the other side, you have this amount. Now, if you omit or cancel pi from upper and lower terms, then on the other side you have 2 pi r. R will go with the square. Then you will get this result, which represents the magnetic amount of magnetic field inside this conductor. What about for external points? For external points, you will have I over 2 pi r. Why? Because for Ampere law, I enclosed will be the total amount of current. So in this case, it will not be depending on the shape of the conductor. It will be the same. For problem 9.6, in the region R from 0 to 0.5 meter in cylindrical coordinate, the current density is given by this equation, and J equals 0 elsewhere. Use Ampere law to find H. So from Ampere law, we know that Ampere law saying I enclosed equal to closed integral H dot dl. Now, how much is I enclosed? I enclosed must be taken from previous equation from chapter 6, which is depending on the current density, and exactly just like done in the previous question. In the previous question, we depend on the current density in calculating the I enclosed. So here you have to apply this formula, which say I enclosed equal to I, which is equal to closed integral J dot ds. How much J is given? 4.5 e2 minus 2r az multiplied with ds. ds here will be differential surface area, which represent the cross-sectional area of a certain cylinder. If I go to whiteboard, just to show you how to calculate it, take a piece of this. How much will be? Sure, it will be, pardon me, may I zoom in just to understand? Okay, let me plot it another way, like that. So this is dr, this is r d phi. Sure, ds will be r dr d phi. For that reason, we selected ds to be r dr d phi here, and taking the dot product between them, then az will gone. You have to perform closed integral. For that reason, you have double integral here. Why? Because you have dr and d phi. For d phi, if nothing mentioned about the angle or the structure to be from 0 to 2 pi, or there is some truncation, I mean, if nothing mentioned about phi, then we'll take from 0 to 2 pi. About radius, you have to take into account whatever given to you in the question. So the solution will be like that. From 0 to r, from 0 to 2 pi. On the other side, yeah, directly he substituted here the whatever he get from I enclosed in the Ampere law. So from Ampere law, we know that the integration of dl will be the length of the circular path will be 2 pi r. Now this to be continued. How to continue this solution? It will be by taking the double integral for this formula, but take care you have r e to minus 2r, so this may be solved by part. You will follow these steps to solve whatever required, and to complete the whole step, then H field will be like given here. Problem number 9.7. In this case, you have a circular loop with radius A. Specialize the result to the center of the loop. He wants to calculate the magnetic field at the center of that loop. So I think nothing mentioned about which formula or which law to be used, but if you think about Ampere law here, you may not get benefit from Ampere law to solve this for this question. For that reason, Biot-Savart law has been used here. To solve by Biot-Savart law, this is R, how we concluded R here. For the point shown in figure 9.14, first he solved it for general point, any point on z-axis. Okay, for that reason, if you take this point and this point will be radius of it will be 0. So may I just take a selection for this figure like that. This point will be 0, comma, with height of, sorry, you will take the angle also. We are talking about cylindrical coordinate, and the height. Height will be h, for example. And if you take this point here, this point will be radius A, comma, for any angle, arbitrary point, and for z equals 0. Now if you think about both of these points, and this is the direction of r, then you have to say 0 minus a, and phi will go with phi, h minus 0. For that reason you get minus a ar plus h az, and so on. Now you have r, you can find the unit vector from it as done here. Then you will substitute in the Biot-Savart law, and don't forget that you have I dot dl from Biot-Savart law. What will be I dot dl here? I dot dl will be a piece of that arc. So if you take piece of that arc, piece of arc will be r d phi, and you have r here, fixed r, it is a. For that reason, it is substituted here to be a d phi. So a d phi representing what? A d phi representing dl. A d phi representing I dot dl. Now this is IDL, a phi, because its direction is given already. Cross product with the unit vector. Now if you perform the cross production in cylindrical coordinate, you get the result to be like that. After getting the result, you have to go to substitute whatever you get in the Biot-Savart law. Then you have to integrate it. To integrate it, you have to integrate with respect to phi. So integration with respect to phi just will be from 0 to 2 pi, because it is complete term, and That's all. You will substitute and you get this result. The important thing here is everything will stay as it is, okay? Why? Because the integration is not done with these things in the denominator, because all of these are constant. Maybe this is variable, okay? But it is done with phi. For that reason, you don't have phi here and here. Integration will be directly 2 pi. It will be just 2 pi. So 2 will go with 4, 2 will be remained, and pi will go with pi. So this will be the result. At edge equals 0, you get this result. I know it is indirect solution. Why? Because in the question he asked to find edge. Find edge on the axis of the, he said first to find edge at the axis of circular current loop to be any point on that axis. For that reason, edge has been taken as a certain height, maybe 0, maybe any other point. Then he's asked for specialize the result for center of the loop. At the center of the loop, we know that edge will be equal to 0. Okay. For 9.11, given the general vector field I equal to this value in cylindrical coordinate, find curl of A at 2 pi 0, at 2 pi 0. So you have to take into account the curl product, which is just like cross product between the vector and differential space differential vector, and by taking the determinant for it, so it is done in cylindrical coordinate. For that reason, you have to follow this identity. Okay. Now, if you want to substitute the A vector is just directed in AZ. For that reason, you don't have direction of R, direction of phi. Both are 0. Just you have this. So after performing curl product, you will get this result. You will get this result and will be simplified to this result. Then specifically at the point required, which is at 2 pi 0, if you substitute, then you don't have R here actually, so just you will substitute in phi, and you don't have Z also, so cosine pi will be -1, sine pi will be 0, so this will be the result, and finally you can write it like that. The last question is number 13. In this question, given the general vector field A to be this value, I think it is a spherical coordinate, and you have just directed in theta direction. Find the curl of A at a certain point, just like done previously. We have to perform the curl operation, but this time will be done for spherical coordinate. So if you perform it, the curl operation will give you this result. And after getting this result, you have to substitute the given point, which is 2 as R, 2, and theta is pi over 2, and phi equals 0. We don't have phi here, you have just theta, so R is given also. You have R here in the equation, so R will be substituted as 2, and theta will be pi over 2, Sine pi over 2 is maximum, which is unity. 10 over 2, it is 5. So you get 5 directed in phi direction. By this, we finish the solution of the problems of chapter number 9, and next lecture will be on chapter number 13. Until that time, I hope you all the best.